Next one is entropy. So next one is entropy. Next another one, thermodynamics point of view, entropy. So some basics we have seen in the last class, right? So in syllabus point of view mentioned as the thermodynamic properties changes. The properties can be changed while changing the temperature, pressure and temperature value. And that type of topics will be mentioned in the syllabus. So that's why no need to discuss all the basic points at this platform. But whenever it is used, I can explain. Now, entropy, right? What is the term? Entropy is S. Can be shown, the symbol is S. Now, this particularly entropy is which is introduced by the class S. Entropy is introduced by the concept which is introduced by the first class S. Why it is introduced by the class S, entropy? That means at the beginning, that means before entropy, whether the particular reaction is the spontaneous reaction or not. Reactants to products, if it is takes place, reactants to products. If some energy is releasing, when energy is releasing, delta is equal to negative, and some of the reactions, while receiving some of the energy, that means we can give some of the energy or we can supply some of the energy, then reaction takes place, that means products formation takes place. So here in this reaction energy is supplied, so that energy delta is equal positive, change in entropy delta is equal positive. When energy is releasing, this type of reactions which is considered as the exothermic reactions, and energy absorption takes place, this reactions which is called as the endothermic reactions. The endothermic reaction naturally which cannot be occurs, so that means we can supply some additional amount of energy. This is happened, so we can here in this process energy is releasing, the excess energy is releasing, so delta is equal negative. Reactants converts to the product, the energy is releasing, delta is negative, exothermic. This is delta is equal to positive, endothermic. Now what is the question arises? That means before entropy, this reaction maybe takes place spontaneously, I mentioned that. That means delta is equal negative. This reactions which is considered as the before spontaneous. When delta is equal negative, these reactions will be considered as the spontaneous reactions before entropy term. And while delta is equal positive, these reactions will be, that means if it is, we can supply the energy, then only the reaction will be takes place. Otherwise it is not takes place. That means these reactions cannot occur spontaneously. Natural process or spontaneous process, or natural process or irreversible process, or all irreversible process which is occurring in the nature, that is spontaneous. It is spontaneously, it can be happen, right? So the flow of water from up hills to the down hills, or heat can flow from high temperature to low temperature region, or expansion of the gas takes place from high pressure region to low pressure region. That means like that, all it may be occurring in the naturally. So that process or spontaneous process. So reactants converts to the products, some energy is releasing, that is considered as a spontaneous process. We can supply some amount of energy, then only the reaction takes place, that is considered as the non-spontaneous process or endothermic process. Non-spontaneous process or endothermic process. That means all exothermic process considered as spontaneous, endothermic process considered as a non-spontaneous process. Before entropy term. Based on this concept can be explained, based on the energy concept, can explain whether the particular reaction is a spontaneous reaction or a non-spontaneous reaction. But these concepts, these energy concepts will be applicable to the limited reactions only. Some limited reactions only it is applicable. Limited reactions. So then another term will be introduced. Another new term is introduced. New term which is introduced by the class S. New term will be introduced by the classes, which the term is entropy. Another one new term or thermodynamic term will be introduced by the classes, that will be the entropy. That means this entropy can explain why the entropy is introduced. That means to explain the spontaneity and non-spontaneity of the reaction, or even though Gibbs energy or Helmholtz energy and some other thermodynamic concepts also, which can be explained whether the reaction will be takes place spontaneously or non-spontaneous. Major concept is like that. So the another one new term will be introduced whenever this energy will be applicable to some limited reactions based on these conditions. So again another one term will be new term will be introduced by the classes. That new term will be considered as the entropy. That means by using the entropy, or entropy can helps us. Entropy can helps us to understood. Entropy can help us to understood whether the particular reaction is spontaneous or non-spontaneous. Whether the reaction is spontaneous or non-spontaneous. Whether the reaction is spontaneous or non-spontaneous. That means by using the entropy, or entropy can help us. Entropy can help us whether the particular reaction, this particular type of reactions, whether the particular reaction, that means reactants converts to the products, whether the particular reaction which will be held spontaneously or non-spontaneously, that can be explained by the entropy. That means entropy is also to explain the spontaneity or not of a particular reaction. That term will be introduced, right? So in which cases it may be spontaneous, which case it may be non-spontaneous, later I can explain. Right? And also entropy, and also by using the entropy, or also entropy can measure the randomness or disorderness of the system. Entropy can also measure the randomness or disorderness of a particular system. Randomness or disorderness of a system. Another one it may be there. One is the helps us to understand whether the particular reaction is a spontaneous reaction or non-spontaneous reaction. One concept. How it is spontaneous or non-spontaneous, later I can explain. The changes also it may takes place, and number of problems also doing, and which different concepts are there. It is related to the temperature, pressure and temperature value, and so many concepts may be there. Later I can explain for ideal gas and ideal solutions, all it may be there. Non-ideal gas, non-ideal solutions also, different concepts can be checking takes place. So that's irreversible process is what, irreversible process is what, I can explain later. But primarily this concept is introduced to explain the spontaneity and non-spontaneity. Another one is, this concept can also measure the entropy, can also measure the randomness or disorderness of a particular system. Randomness or disorderness of a particular system. So now what is randomness or disorderness? Or you know that disorderness, you know that random distribution, it is moving randomly, right? Particles are moving randomly, that means randomness is increasing or disorderness is increasing. If it is in ordered form, randomness or disorderness is less. So that means entropy can also measure the randomness or disorderness. Then entropy increases when randomness of a particular system is increases. Randomness or disorderness is increasing. Randomness or disorderness is increasing, entropy is increases. That means, for example, suppose when a system is considered, suppose we are considering a system. Suppose we can consider a system in water system, in ice, and in the liquid form, that means in the water form, and in the vapor form. Ice, liquid and in the vapor form. These three forms we can consider, suppose. That means in the water system. In the water system. So in this ice form, that means in the solid it may be there. In the solid form. Ice means solid form. In the water form, which one is there? Liquid form in water. Liquid form is there. In vapor form, water vapor form, gaseous form is there. Now, in the solids, which one atoms arrangement is which one? Ordered arrangement is there. In solids, ordered arrangement is there. Well ordered arrangement is there. Atoms are well ordered form. Compared to the solid, liquids are less ordered. Orderness is less. And here in the, compared to the liquid gases, it may be which one form? The particles which are arranged in the disorderness or disorder form or random form. That means particles are moving because due to the weak van der Waals forces in the vapor. Weak van der Waals forces in the vapor, the particles are randomly arranging. That means it is free to move in any direction in the vapor form, in the gaseous form. In liquid form also, here it is also weak van der Waals forces are there, but due to the compared to the vapor form, it may be strong. So that's what here it is, somewhat arrangement it may be takes place, but at some places it may be failure. That means it may be disturbed. But in the ice form, this is a well ordered form. Like a crystal form it may be there. So the atoms are arranged in a regular manner. Right? Even though it may be defects are there, further it is happening, further we can discuss in the solid state point of view, but so it is considered as a well ordered form. That means in solids, suppose we can consider the disorderness or randomness. Disorderness or randomness is increasing in the disorderness or randomness is increasing in which one case? Gaseous form. That means vapor form it may be more, then again liquid form, then again solid form. That means randomness is more in the gaseous form, liquid form, then solid form. Then entropy order is which one? So entropy is which one? I mentioned that entropy is increases while the system randomness or disorderness is increasing, then automatically entropy is increases. That's what entropy in the cases of the gases, the disorderness or randomness is more, then entropy of gases is more than the liquid, then solid. Entropy of the gases is more than the liquid, then solids, right? So this is the entropy. That means if the system is converted or the system is converted to solid to liquid form, while solid converted to the liquid form, right? So what will be happen? This entropy is increases. Entropy is increasing. Why? Because entropy is increasing, disorderness is increasing. Solid to liquid, that means disorderness of the particles is increasing. Next another one, liquid to gaseous form. Liquid to gaseous form. So when liquid to gaseous form it may takes place, then it is system is converted to more disorder form. So that means again also disorderness is increasing, entropy is increasing. Or when solid is converted to the vapor form or gaseous form, vapor or gaseous form. Solid is converted to the vapor or gaseous form, what will be happen again? So solid ordered form to the more disorder form it may be takes place, that means entropy is again increasing. Why? Because disorderness is increasing. Well, because disorderness is increasing, entropy is also increasing. Disorderness increasing, entropy is increasing, right? So that's what I mentioned, that the entropy can also measure whether the particular system disorderness or randomness. Disorderness or randomness of a particular system can measure the entropy. If disorderness is increasing, entropy is increasing, or randomness is increasing, entropy is increasing. And also mention another one or 2 points in the classes. What mentioned the classes? According to the classes, the change in entropy can be measured only. Change in entropy of a system can be measured. So change in entropy of a system, that means initial state of the system it may be suppose SA, while changing the temperature, pressure, some concepts it may be takes place. Final one it may be considered as an SB. The change in entropy delta S is equal final state minus initial state. Change in entropy is equal SB minus SA, like that. That means change in entropy can be measured. Change in entropy of a particular system, delta S is equal Q by T. Delta S is equal Q by T. Delta S is equal whether it is capital Q or small q, whatever it may be mentioned. When Q is equal positive, Q is equal negative, it is there. Q is equal positive, heat absorbed by the system. When Q is equal negative, heat emitted the system. Heat is emitted in that system, and our energy is released in that system. Right? Like that exothermic process, whatever it may be there. So now here it is delta S is equal Q by T is there. Delta S is equal Q by T. This is for the entropy equation. We can consider the class S is given one statement equation, delta S is equal Q by T. Change in entropy, Q is heat, either heat absorbed or emitted. T is the temperature. Now here it is in infinity small process. In infinity small process, ds is equal dq by t. So this is delta is big particle, then d is small, right? Dou is very small, partial. Delta is big, d is small, then delta is very small, right, for a particular system. If infinity small process, in infinitely small changes takes place, ds is equal dq by t. And also from this we can also say that q is equal t into delta s, or from this dq is equal t into ds. dq is equal t into ds, right? And another one statement also given like that, class S. What says the class S? Another one statement according to the class S. Class S can tells us, what says the class S? By using the entropy, or entropy is a state function. This is important one. Entropy is a state function, not a path function. Entropy is not a path function, it is a state function. That means it is a state function means the entropy will depends upon which one? Initial and final states of the system. Final states of the system. So entropy is depends on which one? What is the initial state and what is the final state of the system, not depending on the path. How to reach from initial state to final state is a direct process, or it may be several another process it may be doing takes place. It is not a matter. So entropy is a state function. That means it is depends upon the initial and final states of the system, right? And this is the entropy concept, and units will be taken caloric Kelvin or joules, joule Kelvin. Caloric Kelvin or joule Kelvin. And joule Kelvin or caloric Kelvin, which is considered joules Kelvin. So this is the entropy units, joules Kelvin, right? So we are using entropy in different manners, right? So later I can explain while you can see the systems, right? So this is first concept, entropy, right? So after entropy also, it is also particular limited reactions. Again, free energy terms will be introduced to explain the spontaneity and non-spontaneity of reactions. Gibbs-Feld free energy, Helmholtz free energy. Again, it may be going to take place another processes, even the delta E, delta H also to explain the spontaneity and non-spontaneity. Even the delta S and delta G, delta A, even the chemical potential terms also later I can explain one by one, right? So here in this particular syllabus CSIR point of view, entropy, free energy, and Helmholtz free energy, right, and chemical potential, that systems will be there, right, most probably. Next, another one, change, another one, process. Next, another one, entropy change or change in entropy. Entropy change or change in entropy in variation of temperature, variation of temperature and pressure, variation of temperature and pressure. Temperature and pressure. Entropy, change in entropy, while change in temperature and pressure or temperature and volume, whatever it may be here in this case, two processes which is there, right? One is in the temperature and pressure case, another one is in the temperature and volume case. Suppose first one you can take temperature and volume, suppose. Whatever it may be, you can check while changing the temperature and value. Or variation of the entropy, variation or change, right? Entropy change or variation of the entropy or change in entropy in variation or change in temperature and value, right? Temperature and value. How change in entropy takes place, delta S is what? Suppose you can take n moles of the ideal gas system, n moles of the ideal gas system, moles of ideal gas system you can take. The initial temperature of the system is T1 and initial occupying volume of the gas is V1 and initial entropy is S1. Initial entropy is S1. While temperature is increasing from T1 to T2, our temperature is rises and volume is also increasing. Suppose our volume is changed from V1 to V2, then entropy also changed from the system S1 to S2. When temperature is T1 to T2 and volume is V1 to V2 is changed, then change in entropy is how much? Entropy of the system is how much, right? While temperature is variation takes place from T1 to T2, volume is variation takes place from V1 to V2, what is the entropy change? That is the question, right? Now here in this process, you can take first law of thermodynamics. First law of thermodynamics. Here I mentioned that earlier one, two forms it may be there, first law of thermodynamics. We can consider any of this form depending upon the system. Depending upon the system. That means the work done by the system on the surroundings, by the system on the surroundings, or work done by the surroundings on the system. By the surroundings on the system. Two processes will be there. Depending on that, W is positive and negative, two terms will be there. So we can consider the first law of thermodynamics in any one form. I already mentioned that Q is equal delta E minus W is one form is there. And another one form it may be the Q is equal delta E plus W. Here it is two forms will be there. Two types of forms will be there. Whether it is W is positive, another one is W is negative. I already mentioned that the earlier one, when which case it may be the depending upon the external pressure and internal pressures, the external pressure and as well as internal pressures. P external is greater than internal is what, or P internal is greater than external is what, W value is negative or it may be the positive. That means the work it may be the negative or it may be the positive. I already mentioned that earlier one. You can check them already. You can check them once. In the first law of thermodynamics is mentioned, or in the clearly I can explain later in the problematic point of view. Right? So if it is given like this, plus will be taken, we can consider W is equal P delta V, or if we can consider this one, W is equal minus P delta V. W is equal minus P delta V. While systems it may be changing takes place. Based on that, these two process, so Q is equal delta E plus P delta V is there. If you can substitute here in this case also, then Q is equal delta E plus P delta V is there. Anyone it may be there. W is equal P delta V or W is equal minus P delta V. Depending upon the system, that means work done, external pressures, right, and internal pressures, which one is more? And if the system is compression takes place or expansion takes place, based on the compression and expansions, work done by the system on the surroundings it may be takes place, work done by the system on its surroundings, or work done by the surroundings on its system. Two kind of process will be there. So any one process you can take the first law of thermodynamics, either you can take this one or this one. We can generalize the form it may be considered Q is equal delta E plus P delta V and Q is equal delta E plus P delta V. Q is equal delta E plus P delta V. We can consider that. Q is equal delta E plus P delta V. We can consider any one it may be there. Right, two different forms of the first law of thermodynamics. Two equations are there. We can consider generalized form. This one equation also consider. In some of the cases, this one is also considered. Right, we cannot not mention specific point of view. Either it may be the work done by the system and on the system it is not mentioned. So that's what we can consider. Q is equal delta E plus P delta V. And Q is equal delta E plus P delta V. Delta E is what? Change in energy. And delta V is change in value. Now here it is Q is equal to delta E plus P delta V. This one is considered, suppose, first law of the thermodynamics equation, and by using these two equations. This one is also first law of thermodynamics, or this one is also first law of thermodynamics equation. Then Q is equal to delta E plus P delta V. Q is equal to delta E plus P delta V. Now based on this, in small changes, dQ is equal to, which one is there? dE plus PdV. Or infinitely small changes, dQ is equal to dE plus PdV. Now here it is temperature is changed and volume is changed, pressure is constant, like that mentioned. So dQ is equal to dE plus PdV. Now from the first law of thermodynamics, dQ is equal to dE plus PdV is there. And we know that earlier I mentioned that delta E is equal, suppose this is equation 1, delta E is equal, or CV is equal heat capacity at constant volume. I already mentioned that earlier the basics point of view. Heat capacity at constant volume, which is equal to the change in energy by the change in temperature for 1 mole of ideal gas. That means here it is delta E is equal CV into delta T for 1 mole of ideal gas. If it is n mole of ideal gas, delta is equal NCV into delta T for n moles of ideal gas, or dE is equal to what? NCV into dt. NCV into dt. This is one case. This is equation number 2. That means delta E is equal to what? Or dE is equal to what? NCV delta T. If n moles of ideal gas is there, we can use that relation. And another one, from the thermodynamics equation, you know that delta S is equal to what? Q by T, entropy equation. And ds is equal to what? dQ by T. Or Q is equal to what? T delta S. On infinitely small changes, dQ is equal to TdS. dQ is equal to TdS. Or I mentioned that ds is equal to dQ by T, dQ is equal to TdS. You can substitute, this is suppose equation 3, equation 2 and 3 substitute in equation number 1. Equation 2 and 3 substitute in equation number 1. What will be happen? Equation 2 and 3 substituted in the equation number 1 in this equation, right? So what will be happen? dQ plus is what? TdS. dQ plus is TdS. And dE plus is what? NCV dt. dE plus is what? NCV dt plus P into dV plus PdV, right? So TdS is equal NCV dt plus PdV is there, right? This is the equation. In this equation, right, so what we can find out, change in entropy is what? While the variation of the temperature and value. Earlier I mentioned what you have to find out? Change in entropy. So that's what ds is only you have to find out. That means ds is equal NCV into 1 by T into dt, this T is going to be right side, plus P by T into dV. P by T into dV. And I mentioned that earlier for n moles of ideal gas system is taken, the gaseous system is what? N moles of ideal gas. n moles of ideal gas. That means n moles of ideal gas means what? PV is equal nRT. Then P is equal to what? nRT by V is substituted in the place of this equation. The place of that equation, what will happen? ds is equal to NCV into 1 by T into dt plus, in the place of P what you have to substitute? nRT by V into, already T is there, into dV. Tt is cancellation takes place. What is left? ds is equal NCV into 1 by T into dt plus nR into 1 by V into dV. Now what we have to find out? Change in entropy while changing the temperature and value. So earlier I mentioned that while temperature is changing takes place from T1 to T2 and value is changed takes place from V1 to V2, what is the change in entropy? S1 to S2. Integration S1 to S2. So integration derivation is cancellation takes place near by near. S1 is the initial process, initial stage, and final stage is S2. Upper limit and lower limit, and again here in this case NCV into integration 1 by T into dt. I mentioned that earlier one. Integration 1 by x into dx is equal to what? ln x or log x. I mentioned the earlier one. Log x or ln x. So here it is mentioned as ln of t. 1 by t into dt. Integration 1 by t into dt is ln t. So one time is T1, another one time is T2 plus nR into, here it is also integration 1 by V into dV. With respect to the dV, V function is there. So that's what, which one is there? ln V, upper limit and lower limit. And also I mentioned that the earlier one, if it is, anyone if it is there, upper, if it is, you can apply the limits. So upper limit one time, again another one time lower limit, right? So that's what. So you can substitute, one time is upper limit, another one is lower limit, and NCV into, you can apply it, one time is upper limit, another one time is lower limit, upper limit minus lower limit, plus nR. In the place of V, one time you can substitute V2 and another one time you can substitute V1. Again we can apply ln A minus ln B. ln A minus ln B or log A minus log B formula is there. So which one is the log? A minus log B is there, log A by B or ln A by B. So this formula we can apply. So del S2 minus S1 means change in entropy, and NCV into log A minus log B is log A by B, T2 by T1 plus N, or log A minus log B is log A by B, V2 by V1. Right? Now, this is important equation. Some number of times problems are there. Right? Based on this equation, CSIR point of view, 4 marks questions are there. While temperature, if it is given in the problematic point of view, for n moles of ideal gas system, some temperature is given, 27 degrees centigrade to the 273 degrees centigrade, while heating temperature is increases, and the solution, it may be gas, it may be expansion takes place from V1 to the V2, or it may be the value, it may be changed from 1 liter to the 10 liters. Initial value and final value is given, and initial temperature and final temperatures are given, and what is the change in entropy. Within the bracket, CV value is mentioned. CV is mentioned. CV is equal sum 2 or 3 or like that, it is mentioned, and mention n number of moles, how many number of moles of gas it may be takes place. You can apply this principle. So T2 by T1 and V2 by V1 delta S, which is important relation, right? This important relation, this is one of the relation while change in temperature as well as the change in value. What will be happen? Change in temperature and change in value. How to solve this I can explain clearly. Now, By using this equation, sometimes, or this equation also can be expansion takes place, delta S is equal. So if it is a natural log ln base E is there, so in mathematics I already explained, ln base E is there, exponential, this will be written as 2.303 log 10. ln base is equal 2.303 log base 10. So that's what. So ln is it's converted to natural log. So NCV, that is going to be 2.303 NCV in ln plus log T2 by T1 plus 2.303 NR 2.303 NR log V2 by V1. R is which one? Gaseous constant. R is the gaseous constant. Right? If it is this one equation is also considered as this one or this one. Anyone it may be takes place. Right? Now another one, based on these equations, this is the one concept. Right? Change in entropy with the variation of temperature and value. Next, another one, similar one based on this, similar one it may be there. In thermodynamics, relations are important relations. If you know the relation, it is very easy to attempt the questions in thermodynamics. You know the relation, it is very easy. So, you don't know the relation, you cannot apply or you cannot attempt even a single question in thermodynamics. Thermodynamics are interrelated, not depend upon the particular, the questions are not framed based on the first law only. It is not possible. In CSIR, you cannot expect in CSIR like exams. Right? It is mixing, that it may be mixed in the entropy formula. You can use in the entropy formula the thermodynamics, first law, on second law, like that. Right? So another one change, it may be the variation of the entropy or change in entropy or variation of the entropy with variation of temperature and pressure. Already we have seen the one case, we have seen first one, the variation of the entropy with variation of which one? Temperature and volume. We have already discussion takes place, temperature and volume. Now another one is temperature and pressure. Next one is change in entropy with variation of the temperature and pressure. Now in this case, how the entropy is changed? Delta S with variation of the temperature, that means from temperature is changed from T1 to T2, and with variation of the pressure is changed from P1 to P2. Like that similar manner you can obtain that equation also, or other else you can follow that. You know that change in entropy with variation of the temperature as well as volume, variation of the temperature as well as volume. You know that equation. Which one is the equation? Delta S is equal 2.303 NCV log T2 by T1 plus 2.303 NR log V2 by V1. This equation, you know that while changing temperature and volume, from this equation, if you can take this equation, suppose this equation is equation number 1, you can take this equation. You know that earlier one I mentioned that Cp minus Cv is equal to what? R. Cp minus Cv is equal to R. Cp minus Cv is equal to what? R. I already mentioned that the earlier one. Right? When Cp minus Cv is equal to R, right? From this, Cv is equal to what? Cp minus R. Cv is equal Cp minus R, or Cp is equal Cv plus R, Cv is equal Cp minus R. So that means in the place of Cv you can substitute Cp minus R. Next, and you know that according to the ideal gas system, PV is equal to nRT, ideal gas equation, you know that familiar ideal gas equation, PV is equal to nRT. And from that, well, pressure is V1, initial pressure, volume is V1, N is the number of moles is constant, suppose temperature is T1, R is constant, and N it may be constant, we'll putting that. So, and final states of the system, N, R is a gaseous constant and number of moles it may be constant, N are T2. By using these two relations, initial conditions and final conditions from this gaseous state, P1 V1 by T1 is equal, the variables which can be fixed like that, N, P1 V1 T1 and P2 V2 T2. So by using this, which one? NR. P1 V1 by T1 is equal to NR. And from this, P2 V2 by T2 is equal to what? NR. Here it is also. These two will be NR. Then what we can say that relation is P1 V1 by T1 is equal to what? P2 V2 by T2 from this gases relation, right? Gases equation relation. P1 V1 by T1 is equal to P2 V2 by T2. From this V2 by V1 place, that means this V1 is going to be in the right side, V2 by V1. Then what will be happen? P1 into T2 and by this P2 here in this position and T1 is there. This is equation 3 in this position. Equation 2 in this position. That means equation 2 and 3 substitute in equation number 1. This plus Cv plus and V2 by V1 plus. That means delta S is equal 2.303 N. Cv plus is what? Cp minus R log T2 by T1 plus 2.303 NR log, in the place of V2 by V1 what you have to write? P1 by P2 into T2 by T1. P1 by P2 or P1 T2 by P2 T1. Right, that one we can substitute. Right? So just the earlier one equation when be taken, and in the place of Cv and in the place of V2 by V1, just small changes takes place. Direct step also it may be given. We can also apply direct step also, but it may be further if it is slowly the topic is moving, I can apply the direct steps also, because in the examination process, examination point of view, time consuming process, so we can use the direct steps, right? So delta S is equal to, what will be happen? 2.303 NCP log T2 by T1 minus, on simplifying takes place, 2.303 NR log T2 by T1 plus, this is which one we can write? Log A into B form. Log P1 by P2 into T2 by T1. This is considered as A, this is considered as B. Log A into B principle is what? Log A into B is equal to log A plus log B. Log A minus log B is log A by B. Log A plus log B is log A into B. So that's what we can apply that principle, 2.303 NR. One time we can apply log P1 by P2. Log A plus log B. That means log P1 by P2 plus log T2 by T1. So this 2.303 NR into. So that's what I can mention direct step. 2.303 NR into log, which one? T2 by T1. P1 by P2 into T2 by T1. So because log A plus log B, log A plus log B into 2.303 R. Now here in this equation, this term and this term will be the cancellation takes place. Right, what will be left? Delta S is equal to 2.303 NCP log T2 by T1 plus 2.303 NR log P1 by P2. Right? So this is the which one equation? While change in pressure and change in temperature, that means variation of the pressure from P1 to P2, temperature from T1 to T2, what is the change in entropy? In this earlier one, T2 by T1, but here it is which one is there? V2 by V1 is there. In this case, P1 by P2. According to the Boyle's law, what is that? V is inversely proportional to the P, according to the Boyle's law. That means volume is V2 by V1 and pressure is P1 by P2. If this denominator and numerator can be interchanging takes place, suppose what will happen? Minus we can add. So that means, or this equation is also sometimes it may be given 2.303 NCP log T2 by T1. So in the place of P1 by P2, if in exchange of this denominator and numerator, P2 by P1 minus we can add 2.303 NR log P2 by P1 also, but what will happen? Minus instead of plus, minus term is there. This one equation is also there, change in entropy. Or if 2.303 you can ignore, suppose what will happen? This equation will be mentioned NCP ln base E form. 2.303 you can ignore, NR ln P1 by P2, or if it is P2 by P1, minus is there. So these equations which are considered as the variation of the entropy with variation of the temperature as well as the pressure. Right, in CSIR point of view, these questions are there, these relations are there. Based on these relations, questions also there. I can explain the problems at a certain point. Right, so you can first we can discuss the some of the concepts. Later I can explain the questions, right, the problems also. Right, so these relations also important relations. Okay, next another one is what? Next one. So we can see the change in entropy for variation of the temperature and pressure as well as the temperature and volume. We are already discussion takes place. Enough discussion takes place. From that principle also we can obtain relations. Also we can obtain. Next, in that process, if the process is isothermal process. If it is an isothermal process, if the process is isothermal, so what will happen? So if the process is isothermal means, what is that isothermal means? Temperature is constant, change in temperature is 0. Change in temperature is 0, temperature is constant, isothermal process. I mentioned that earlier one in the basics cases. So that means what will happen? T2 minus T1 is equal 0. That means T2 is equal to what? T1. Temperatures will be same and constant, the dt is 0. Not temperature is not 0. Temperature is constant, change in temperature is 0 in isothermal process. Now, if you can take this change in temperature and volume relation, what is that relation? 2.303 NCV log T2 by T1 plus 2.303 NR log V2 by V1. This relation is there, one relation. While change in entropy with temperature and as well as volume changes takes place. From this isothermal process, from isothermal, what will happen? T2 is equal to T1. When T2 is equal to T1 is there, what will happen? This one is cancellation takes place. That means this one is equal, this one is cancellation takes place. That means what will happen? Log 1 is left. When log 1 value is what? 0. Logarithm of 1 value is 0. I mentioned at the table. In the quantum mechanics point of view, in the operator's case, I mentioned very beginning, in the quantum mechanics unit, I think it's part 4th or part 5th, the operator's point of view, I mentioned all these mathematical principles. That mathematical principles we are using in further, either it may be the quantum mechanics or entire physical chemistry point of view, we are using the around 40 to 50 mathematical principles only. If you know that mathematical principles, this total physical chemistry is very easy, even though you are a biological background student, right? No need to worry. Right. So T2 is equal to T1 if it is there, log 1 is there, that log 1 value is 0. That means log 1 value is 0, this value is, it may be 0. Plus what will happen? This value is 0 plus 2.303 NR log V2 by V1 is there. Right. That means if the process is isothermal process, delta S is equal to what? 2.303 NR log V2 by V1. Or 2.303 if you can ignore, that what will happen? Delta S is equal NR LN V2 by V1. If log by ln base E, this is base 10, log is base 10, ln is base E exponential like that, E. So if it is called ln is converted to log, ln is going to be log, which one is there? 2.303 log base 10, ln base E is equal to, right? So this 2.303 log base is what? ln, right? NR ln V2 by V1. And another one relation, we know that while change in temperature and pressure case, 2.303 NCP log T2 by T1. In case of pressure and temperature case, NCP. In case of temperature and volume case, NCV. Heat capacity at constant volume is CV, heat capacity at constant pressure is CP. CP is equal to what? Delta H by delta T. Or delta H is equal to what? Cp into delta T. If N moles of ideal gas is there, NCP into delta T. Like the delta E is equal to NCV into delta T. E and volume, energy and volume is the relationship is there, and enthalpy and pressure it may be relationship is there, right? That relations also extended to that Maxwell equations case also, or Gibbs equations case also. There is a relation is there, energy and volume and enthalpy and pressure. Enthalpy is H and constant pressure. Energy if it is there, CV is there, value. Right? Now, this relation, we are using that relation, temperature and pressure variation takes place. So 2.303 NCP log T2 by T1 plus 2.303 NR log P1 by P2. Right? Not P2 by P1. If it is P2 by P1, minus is there. Now, if the process is isothermal, what will happen? T2 is equal to T1. T is constant, delta T is 0 and T2 is equal to T1. I already mentioned that. So that means T2 is equal to T1. If it is substituted, this one is cancellation takes place because T2 is plus T1 or T1 plus T2 you have to substitute. Then what will happen? Log 1 value is 0 like this earlier one. Right? That means 2.303 NR log P1 by P2. or if it is P2 by P1, minus is there, right? Or delta S is equal 2.303 log place. Suppose natural log ln is there, so ln it may be, you can return n or L and P1 by P2, that means ln base E, right? Here in this case log base 10, nr ln P1 by P2 or nr ln V2 by V1. So if the process is an isothermal process, this will be happen, right? These two equations. If the process isothermal process in terms of pressure and in terms of value, right? And also sometimes in the problematic point of view, the CP value, CV values are not mentioned. Monoatomic gas, diatomic gas, triatomic gas is mentioned, suppose. So for monoatomic gases, like helium, neon, like that, right? So CP value and CV value. CP value is 5 by 2 R and CV value is 3 by 2 R for monoatomic gases. And gamma is also one relation is there. Later I can explain the ratio between the CP and CV, which is mentioned as gamma. That means gamma is equal CP by CV. That means 5 by 2 R by 3 by 2 R. 2 is cancelled and RR is cancelled. What will be happen? 5 by 3. Gamma is equal 5 by 3. Next, for diatomic gases, for H2, O2, N2, like that, diatomic gases, CP value is 7 by 2 R. This CP and CV values will be depends upon the transitional and rotational degrees of the freedom. In gaseous state point of view, clearly this how to obtain these values can be explained. So 7 by 2 R, 5 by 2 R for diatomic gases. So this gamma value is what? This 7 by 2 R by 5 by 2 R, this RR is cancelled, 2 is cancelled, what will be left? 7 by 5. Next, for triatomic gases. Diatomic gases, you know that. Monoatomic gases, triatomic gases, CP value is 4R, CV value is 3R, gamma value is what? 4 by 3. Right? This is the CP, CV and gamma relations. So if you sometimes in the examination point of view, whenever it is CV is necessary, but CV is not given, CP is given. Or sometimes you can substitute the CP value, suppose the change in entropy with the temperature and pressure, it maybe takes place. What will be the equation? 2.313 and CP. But CP is not given in the examination point of view, CV is given. That means how to convert that CV is to CP? CP minus CV is equal to R. Or CV value, if it is given, CP is not mentioned. If it is given like this equation, CP is equal to CV plus R. That means 3 by 2 R plus R. That is 5 by 2 R. Then 5 by 2 R plus R, 7 by 2 R. 3 R plus R, 4 R. Right? CP is equal to CV minus CV plus R. Right? You can use that relations also. Right? So this is which one? Whether the process is an isothermal process, how to obtain that relations. The process is an isothermal process. Now another one case. The process and isobaric process is what? Isochoric process is what? Isothermal, you know, check them. You are already checked them. Isobaric is what? Isochoric is what? So if the process, isothermal process, already we have seen. If the process is isobaric process, if the process isobaric process, what will happen? Isobaric process. If the process is an isobaric process, I already explained that pressure is constant. That is considered as an isobaric process. That means change in pressure, that is 0. Whether it is constant, change in pressure is 0. That means what? P2 minus P1 is equal 0. That means P2 is equal P1. So which one equation we are using in the entropy changes process? Not using temperature and value. We are using change in temperature and change in pressure. How to change the entropy? Right? That means delta S is equal 2.303 NCP log T2 by T1 plus 2.303 NR log P1 by P2. This relation we are using. From this relation, what will happen? P2 is equal P1 is substituting takes place. In the place of P1, P2 is substituting takes place, or in the place of P2, P1 is substituting takes place. It is cancellation takes place. When it is cancellation takes place, log 1 value is what? 0. That means which one is remaining? Delta S is equal 2.303 NCP log T2 by T1. If it is mentioned in the examination point of view, if the process is isobaric process, what is change in entropy? If T2 is given, T1 is given, and N value is given, Cp is given, N is number of moles is given. Or you can use the formula delta S is equal NCP Ln T2 by T1. Instead of 2.303 log, we can write the Ln base E. Next, another one process. If the process is isochoric process, what will happen? Isochoric process. I mentioned that earlier one, when it is the process and isochoric process, temperature is constant. Volume is constant. With the process is isochoric process, volume is constant. Isothermal temperature, isobaric pressure, isochoric is what? Volume is constant. I mentioned that earlier one. When it is volume is constant, change in volume is 0. That means V2 minus V1 is equal 0. Then V2 is equal to V1. So we can take which relation? Change in temperature as well as the value. So that means entropy change case, log T2 by T1 plus 2.303 N or log V2 by V1. This relation we are considering. From this relation, we can substitute in the place of V2 plus V1, you can substitute. V2 is equal to V1. V2 is equal to V1 in the place of V1, V2 or V2 plus V1. So it is cancellation takes place. So that means log 1 is left, log 1 value is what? 0. So that means, what is the equation? Delta S is equal 2.303 NCV log T2 by T1 or NCV Ln T2 by T1 from this format. NCV Ln T2 by T1 or 2.303 NCV log T2 by T1. Now, another one process. If it is an adiabatic process, what will be happen? In the adiabatic process, two cases will be mentioned. Adiabatic reversible process. In the adiabatic reversible process. So the change in Q is 0. Right, Q is constant, dQ is 0. When dQ is 0, ds is equal dQ by t. That value will be Q is 0. That means delta S is equal 0. Delta S is equal 0. Change in entropy, because Q is 0 in the reversible process, then delta S is equal 0. Delta S is 0 in the reversible process. When delta S is 0, what will happen? S is constant. S is constant, delta S is 0. Right? Isoentropic process. This process is called as an isoentropic process. S is constant means which one? Isoentropic. Isoentropic process. Q is 0, then delta S is equal to Q by T. That value is 0. Next, another one. In the adiabatic, irreversible process. Now the process is irreversible. The process irreversible, irrespective of the process, irrespective of the system. The process is irreversible. All irreversible process or irreversible process occurring spontaneous. In all spontaneous cases, delta S is positive or delta S is greater than 0. From that, in adiabatic irreversible process, delta S value is greater than 0 or it may be the positive. Why? Because the process is an irreversible process. Right? Whenever it is required, we are using that relations. Right? So this is the system is isobaric is what, isochoric is what, isothermal is what, right? And adiabatic system is what. So I can explain.